Hi everyone, welcome back to Workshop, and it's part 2 of the PCB / product production video. I'll link part 1 down below, and in this part 2 video I've actually finished the SMD assembly of my PDVS2 minis, and I just thought I'd run now through the testing process and the building up of the final product. So let me take you over to where I've got to with the SMD assembly, and then we'll take you on to testing after that. So here's the actual PCBs themselves. Initially I'm going to concentrate on the charger boards, which I'm going to test in a second, but I just thought I'd show you the actual main boards. I've not quite finished the assembly of those. The main side of the board where all the components live, all the SMD components live, they are all done and dusted, and I've just got the switches and a few connectors etc. to put on this side here, as well as the actual LM399AH itself, but I'll come to the assembly of that later on. For now we're going to concentrate on the actual charger boards. Okay, to test these boards I like to do it independently from the main PDVS2 mini board, so I built up this little test jig that allows me to do that. So what I've actually got is a couple of headers on this board here, which actually allow the charger board to just plug in like that, and it makes it very fast for testing one and moving on to the next one and the next one, etc. But what you've also got is the batteries are connected to this board. I've got a switch on here that simulates the logic signal from the main PDVS2 mini board, and that just either switches on or switches off the charging circuit. I've got a fuse in line with the actual battery supply in case there's any short on the charger board that might short circuit the batteries, and this little tail here is just used to apply power to the actual charger board. 3 multimeters are actually connected to it as well. The 3.3 volt is measured on the right hand meter, then the output voltage from the main charger circuit in the middle meter, and on the Kawitz meter I'm measuring the current to the batteries. So let me plug in the board here. Let me hook up the supply to the board. Now the reason I've got a tail doing that is because the actual connector that the DC input should come into is actually pointing down the way, so I can't reach that. And then I've got a 20 volt supply here which just plugs into the back of my test board, and immediately you can see I've got a 3.3 volt supply there, so that's working great. Off camera I'm measuring about 6 milliamps at the moment supply current, which I know is around about the right figure. I'm already getting an output voltage that's 20 volts minus the Schottky 0.3 volts supply, so that's why I'm getting 19.7, and of course I don't have the batteries connected yet, so I'm getting 0 amps to the batteries. So now we can connect the batteries up. Just a case of plugging those in, and immediately you can see I'm getting about 220 milliamps charge current to the batteries. That's exactly what it should be. I'm still getting my 19.4 and I'm still getting my 3.3 volt supply. Now I'll simulate the logic signal from the main PDVS2 mini board. I'll just hit the switch and we should see the charge current drop right down to 0, and the other two should stay roughly as they were. And usually what I do is I flick it back and forward just to make absolutely sure that that's working. And there's one other thing I like to do. There is actually a 4.2 reference supply that goes to the charger IC on the board, so I like to measure that just to make sure that that's absolutely perfect, and because it's crucial to the charge. Oh, one of my meters has just switched off. That 4.2 volts is actually crucial to the charging of the lithium ion batteries. So let me just go on to one part of the circuit here. There we go. Oops. There we go. 4.2 volts almost exactly. And there is actually a pin on the actual charger IC which splits that in half. So I like to measure it as well. 2.085 volts. Perfect. So this charger board is working perfect. Well, there we go. All the charger boards are now fully assembled and fully tested. I tested about 51 of them in this batch, and only one didn't work, and that was a surface mount resistor I'd forgotten to fit. So not a bad result for that quantity of boards. The next thing is the main board. I've gone ahead and actually fitted the push button switches, hand soldered them, and the sockets, a header, and as an LED tucked down in there. So how do I go about testing these? Well, the problem is, or part of the problem anyway, is the 3.3 volt regulator for most of the supply for like the processor etc. actually lives on the charger board. So what I actually do is just give this board a good visual check. The soldering, as I showed in the last video, is usually pretty good from the reflow oven, so there's not that many shorts or anything like that I would normally find. It's normally quite good. The main problem might be, as per the charger board, maybe I've forgotten to fit a component or something like that. So what I actually do is, after giving the board, the main board, a good visual check, I actually go ahead and solder up the charger board to the actual main board like that there, and then I can power up the whole unit via the DC socket here, which lives on the charger board. Now the additional problem with that is, as you can see, the charger board's actually quite loose in the holes in the PCB. Now I could have designed the main board so it was a tighter fit around the pins, but sometimes when you buy these right angled headers here from the supplier, they're not a perfect right angle. So that would cause, if I soldered it up, the board to be a slight angle, and I do like it to be a perfect right angle. So I actually have a jig that I've made up and I use to ensure a perfect right angle, and also to speed up the assembly of all the boards in the batch I'm working on. And here is the jig. It's just a 3D printed part glued down onto an aluminium base, and what it's actually got is a couple of channels there where the charger board will sit into, and the main board will locate itself in these slots on the top of those 4 pillars there. And by doing that, if I can just assemble this one up there, it's a nice tight fit, and what you end up with is more or less a perfect right angle and at the right height etc. of the main board and charger board on the jig. And then all I have to do is hold it down very slightly, and I can basically just run the soldering iron along those pins. So I'll go ahead and do that one now, and then we can proceed to the next step. Okay, that's it all soldered up. So the next thing to do, actually, I need to upload the firmware to the processor, because it's completely blank at the moment. That's the way I assemble them onto the board. And the way I'll do that is, I'll actually put in 5 volts into the DC input socket. That'll enable the 3.3 volt regulator to work. And there we go, I've bypassed the soft power switch circuit with this little jumper on the side there. As you can see, 5 volts input, and I'm drawing about 7.5 milliamps. It should be less than 10 normally, and I'm getting a nice 3.3 volt supply. So with it powered up, now I can upload the firmware to the actual processor. Now the programmer I actually use is a Dataman 40 Pro, and I use it via its ISP header on the side there, and with the necessary mating connector here, which I can plug straight onto the PDV-S2 mini board. However, I never used to use the Dataman 40 Pro. What I actually used to use were these AVR ISP2s, a proper genuine AVR here, and a Chinese clone I've actually modified. And although they work great, what I found was that if you use this one here and you got all the drivers loaded up under Windows 10 and then switch to this one for whatever reason, it would load a different set of drivers in it, well, or maybe the same set of drivers but in a different mode, and therefore when you came back to this one wouldn't work. So I then had to use a program called Zadig under Windows 10 to manually enable the drivers for depending on which one I wanted to use, and I got absolutely fed up of doing that. With the Datamin, it's got its own bespoke drivers, therefore it's always going to work, no matter even if I've used these ones in the meantime for some other purpose. So these two have been retired now, and I just use the Datamin. But there is one other issue, and that is I'm sitting about 6 feet away from the keyboard and mouse for my development PC where the Datamin software is running, and I'm working at the workbench with the programmer handy. How do I actually hit the go key in the Datamin software in order to initiate the programming? Well, I actually use a Bluetooth numeric keypad here, and I've got this coded up under Windows 10 to simply send keys to the Datamin app, so that this here sitting locally on the workbench here between boards, I just assemble up the new board, get it ready, and I hit one button on the Bluetooth keyboard and off it goes, programming the next PDV-S2 Mini. I never actually need to refer to the Datamin software, so this has been quite handy. Now the Datamin program itself does actually have a yes button on it specifically for this very purpose, but there is actually another step that you need to do on the Datamin software, and it just makes it slightly easier if I just use my own Bluetooth keyboard. So with PDV-S2 Mini now programmed with its firmware, the next thing to do is fit a test LM399 and my test LCD to it. I don't solder in the LM399. I've actually got one here that I changed the pins on, so they're slightly thicker pins, and it's a nice interference fit on the holes in the PCB for the LM39, so it gets a good contact, so I can fit it and then remove it again and move on to the next board. The reason I don't fit the final LM399 to the board at this stage, because it still needs to be run through the ultrasonic cleaner, and I'm not putting LM399s through an ultrasonic cleaner. I also want to go ahead and actually ramp up the DC input supply and check that there's various DC supply voltages from the additional regulators on the board to make sure they are working, and also test the Zener voltage and reference voltage on the circuit board as well. Part of the testing process. So let me set that up now. Now we have the next problem, and that is I'll be probing the board on the back on the various test points to measure the supplies, but how do I then ramp up the power supply, keeping good control over whether I don't have any current overload or anything like that? Well, I don't really want to reach across the workbench to actually vary the supply here. It's a bit too hit or miss. And when you're in a production environment like this, I want to go direct to a specific voltage at a specific time. So what I've actually got is a little homemade keypad here that I've attached to some digital inputs on the power supply, and I've got a script that I can run on the BB3's software which will allow me to step up between a set series of voltages on the actual power supply. So let me just call up that script. Here we go, PDV-S2 Mini, and that's it. And now currently it's set to 5 volts. I can go down the way to 0 volts. Next one up is the 5. Then we've got 8. Then we've got 12, 15, 20, and that's the top end. So very easily I can switch between any of those voltages, and that allows me to test out the various supplies on the PDV-S2 Mini very easily, and I can keep this pretty local to my hand next to the PDV-S2 Mini. So I've currently got 5 volts back in again, and 3.3 volts is perfect. The next thing I want to check is there actually a minus 0.2 volt supply. Yep, minus 0.2, that's good. And the next one is a plus 5.4 volts, but I'm not going to get that just yet. I need to go up to the next supply on the BB3 power supply, so I'll hit the button. 5.4 volts, that's looking good. And the next one after that is the 11 volt supply. I'm not going to get that until I get up slightly higher. Just check the plus 5.4 again. Yeah, so plus 11 should be on the next press of the button. Yep, 10.8, that's good enough. So plus 5.4 minus 0.2 plus 3.3, and the next one will be the LM399 that I've got fitted, and 7 volts, that's quite correct, should be there or thereabouts. And the actual VREF itself should be just over 5 volts, perfect. And now I'm ready to actually power up the board without the soft power switch jumper on, and we should see something on the LCD. There we go, perfect. Now whilst I'm here, I do actually like to test the output voltage from the actual PDVS2 Mini. It's not calibrated, but let's just see what we get. I'm getting round about 0 volts. I usually skip all the way up to 10 volts, and yeah, I'm getting 9.7 volts. That's par for the course for a totally uncalibrated board. And just to double check, down to 5 volts, and I should see, yeah, 4.9 volts. That's good. This board is probably working perfectly. So the next step is actually I'll go ahead and do exactly the same on the rest of the boards in this batch, and then we'll take it to the next stage after that. So the next thing I'd actually do is remove the LCD, remove the dummy LM399, and then ultrasonic clean the boards once I've got them all to the same stage. Now I'm not going to bother showing you that, I've showed you that in previous videos, so I'm going to skip to the next step. Is once they're cleaned, I would then assemble the real LM399, the battery holders, the LCD, the banana sockets, and then it's just a case of dropping it into the aluminium housing and putting on the keycap, then screwing on the acrylic cover. But I'm not going to bother showing that. The end result is a PDVS2 Mini like this. But then of course it does actually need calibrated, which is what I'm going to show you now. So I've got it hooked up with my Teflon cable to my 3458A multimeter, and now we're going to go over to my Windows 10 PC where I've got my software I'm going to use to automate the calibration of the PDVS2 Minis. The reason I have to automate it is because there's not just 2 set points, i.e. 0 volts and 10 volts, and then the microprocessor would work out the corresponding X and Y between the two. There is actually distinct set points, calibrated set points for each volt, so you've actually got 11 in total. Automating the calibration with so many set points is actually quite crucial, otherwise you'd be standing over this keyboard for I don't know, 20 minutes at a time calibrating each PDVS2 Mini, and I just can't do it with the batch numbers that I've got, so I've automated the whole process. So the way the auto calibration actually works is I generate a control loop. I've got the PDVS2 Mini's output connected to the multimeter, but I now need to be able to instruct the PDVS2 Mini to go from 0 volts to 1 volt to 2 volt, 3 volt, all the way up to 10 volts during the calibration process. So how do I do that? Well, there's actually a serial header on the front of the PDVS2 Mini there, and I make use of these adapters here to connect that via USB to my Windows 10 PC, and that connects up this entire control loop. So I'll do that now. So with it connected, the next thing I do is enable the serial comms, and you can see that the LED's flashing there. That's every packet going out. And the next thing is just put the PDVS2 Mini in calibration mode and just leave it sitting like that. And now over to the software on the PC. Okay, so I've got the PDVS2 Mini software up and running. As you can see, I've not configured anything. So first thing, over to PDVS2 Mini tab, select the COM port that's connected via that USB interface and start it up. and as you can see it's connected to the PDVS2 Mini. I've got some numbers on there, etc. And back to the GPIB network, and here's device number 1. I've currently got selected a GPIB address 22, that's my 3458A, and I can connect right here. And that's it connected there successfully. Back to the PDVS2 Mini tab. What you've got down here on the right hand side is all the calibration X and Y information for 0 volts all the way up to 10 volts. That's that 11 set points. You've also got the calibration for the battery indicator, the charge milliamp, and the output voltage monitor, which we can also tweak the values of. So when I connected to the PDVS2 Mini, it went ahead and read the internal memory back out into this app here, and you can see those numbers down there. That's just the dummy initial information via the firmware, and these are the numbers that we're going to be looking to change. Over on the left hand side, I've got all the buttons for controlling, starting and stopping the calibration. So we'll hit the first button, get all cal data from the PDVS2 Mini. Don't need to press this, but it's a nice little check. So now we'll run a full auto cal from scratch. Don't need to do anything. All these details here regard to controlling the calibration are all automatically set. All I need to do is press this button here. So run full cal. So down here is the status. It's setting the pre-cal values and off it's running. And what it's actually doing is it's stepping up or stepping down the output voltage on the PDVS2 Mini one small step at a time, as you can see there, until the 3458A reads back the voltage that we're looking for, i.e. exactly 1 volt, exactly 2 volts, exactly 3 volts, etc. Now this first run is just a basic check. It's not going to go down to the 5 decimal places. So we'll just let that run. It's usually pretty quick, as you can see there. We're already on 9 volts. And here is the set voltage here. Calibrating the 10 volts. Just about finished. So what it's doing now is it's doing the final calibration, a much more accurate setting of the X and Y values. And as you can see here, it's recorded the first one, the 0 volts one, as it goes off and does the 1 volt one here, and it'll run through all of them until it finishes all 11 set points. As you can see here, that's the 1 volt one done. Now all this is set with an MPLC of 20. I do go back in at the end when it's finished, set it to 100 and do a manual check of all the set points at the end. Just about finished the 2 volt one now. That's it done. As you can see, it's still pretty accurate there. And over at the right hand side, you can see that's the actual count value as it's stepping up or stepping down as it tries to locate the most accurate output on the PDVS2 Mini. And whilst it's doing that, all this detail down here is just configuration data from the PDVS2 Mini, the low battery alarm set point and the shutdown set point. All those are user adjustable as well, but the firmware has them set for the normal operating values, so I just leave them. There's nothing for me to change there at all. And down here is just the basic status information from the PDVS2 Mini. So that's 5 volts it's working on now. And whilst it's doing that, up on the left hand side here, you can see this I/O devices window. This is where all your GPIB devices will be displayed and what their current action is. And as you can see, it's continually doing a read there, a single read, and that is just this app controlling the GPIB network. And before I had this app, I was doing it all manually on the PDVS2 Mini itself. And that was a case of a lot of sore fingers at the end of a large batch of PDVS2 Minis. So we're now working on the 8 volt setting. Up here we've got the Delta microvolt display. That'll come into action in just a second once it's finished the 10 volts. And that's them all finished. So now I'll do a manual check of all the set points. I'll set the MPLC to 100. There we go. And I'll just press the set button on the 0 volts. So what it's doing now is it's setting the PDVS2 Mini to 0 volts output, and it's going to display for me at that count value of 2459 what the Delta microvolts value is away from 0 volts requested. As you can see, it's minus 10.8 microvolts. Now if I don't like that figure, or it's too high by maybe 1 count or something like that, I can adjust the count value manually, but with these arrows down each side. So let's try raising it up very slightly, 1 count, so it's 2459. Let's go to 60 and then hit the set button again. With an MPLC of 100, it will take a second or two longer to get the value back from the 3458A. And there we go, minus 2.3. I'm not going to get much better than that. And then I can go on to any of the voltages I like, but I usually just run right down them all. So I'm doing the 1 volt one now. Minus 1.9, that's fine. So let's skip down to the 10 volt one. Let's just set that one. 1.3, that'll do nicely. And let's take a look over here. So with the PDVS2 Mini set to 10 volts, the voltage output monitor on the PDVS2 Mini itself is recording 9.96. Now in a brand new board that might be reading 9 volts or 11 volts or something, so I can actually adjust that figure there, and that's what this one along here is. I can adjust it up or down accordingly. And down here on the calibration certificate, I like to offer the actual real value recorded by the 3458A at various voltages here, from like 0.1 of a millivolt all the way up to 500 millivolts. And that's just to add them to the calibration certificate. Like for instance, I can set 500 millivolts, and then here it will give me the voltage. It's doing a couple of reads, not just the one, and you can see that set to half a volt, 500 millivolts, it's going to output that voltage there. Of course, I've got this acrylic front panel, so let me take you over to the laser cutter and I'll show you how I go about cutting and engraving those panels. So some of the hardware I've got to prepare for the PDVS2 Mini is the actual front panel, and I actually cut my own acrylic front panels. You can see one here that is nicely finished there, and this is what it looks like once I've laser cut it. So I've got my laser cutter down here. I'm going to fire that up. I'm going to put a panel in, and let's cut it. Well, I hope you can hear me over the noise of the actual laser cutter. It's actually got a water cooler underneath it, and there's a large pump in there, so it's actually quite noisy. So this was originally a K40, one of those cheap Chinese laser cutters, but it basically resembles very little from what I originally purchased. I changed out the controller board on it, I fitted an LCD onto the front panel. It's a new front panel that I made up, where I've got the current for the actual laser tube displayed. I can control the current through the laser tube on the milliamp set there, and I've actually also fitted a Z bed, a motorized Z axis on the actual bed of the laser itself. And what that allows me to do is control the height of the item that I'm laser cutting directly from Lightburn software. And there we go, 3 panels all cut, and eventually I'll peel off the film and we've got a nice panel for the PDV-S2 minis. So I'll get on, 3 panels per sheet. I've got a lot to do. So with the newly engraved front panel fitted, there is the final PDV-S2 mini. So I hope you like these 2 videos. Been meaning to make a video like this for a long time. How I go about manufacturing the PDV-S2 mini, all the way from assembling the circuit boards, testing and everything in between. So if you like the video, comment down below and don't forget to subscribe. Thanks for watching.